The cloud has become one of the most familiar words in modern technology. Every day, billions of people save photographs, stream movies, backup files, send emails, and interact with artificial intelligence through services described as living in the cloud. The name encourages a simple assumption. Information appears to exist somewhere above us, always available, always connected, almost without physical form. The reality is remarkably different. The cloud has never existed in the sky. Every photograph you upload is stored inside a physical storage system. Every video you stream is delivered from a physical server. Every AI conversation is processed by physical computers operating inside highly specialized facilities. These facilities are known as data centers. Some are so large that they contain hundreds of thousands of servers operating simultaneously. Together, they process an extraordinary volume of the world's digital activity every second. Their existence reveals an important characteristic of modern civilization. The technologies that appear the most invisible often depend upon the largest physical infrastructures ever constructed. Behind every cloud application exists buildings, electricity, cooling systems, networking equipment, fiber optic cables, and thousands of engineers responsible for keeping those systems continuously available. The convenience people experience every day is the visible result of an invisible architecture operating without interruption. Understanding that architecture changes more than the way we think about technology. It changes the way we understand modern civilization itself. Because before information can move, before artificial intelligence can respond, before businesses can operate online, someone must first build the infrastructure that makes all of it possible. If the cloud does not exist in the sky, where does it exist? The answer is surprisingly simple. Inside buildings. Enormous buildings. Purpose-built facilities designed to store, process, and distribute digital information every second of every day. These buildings are called data centers. At first glance, they appear surprisingly ordinary. Large warehouses, minimal windows, highly secured perimeters, very little architectural decoration. Their importance is almost impossible to recognize from the outside. Inside, however, they contain one of the most sophisticated infrastructures ever engineered. Hundreds of thousands of servers operate continuously. Networking equipment routes enormous volumes of digital traffic. Storage systems preserve unimaginable amounts of information. Cooling infrastructure removes the heat generated by millions of electronic components. Backup generators stand ready to operate within seconds if external power fails. Every layer is designed around a single objective: continuous availability. Because unlike traditional offices or factories, data centers are not expected to close. The modern digital economy assumes they remain available every minute of every day. Even a brief interruption can affect financial markets, healthcare systems, transportation networks, communication platforms, and cloud applications used by millions of people simultaneously. Reliability therefore becomes more than an engineering objective. It becomes part of the architecture itself. This explains why cloud infrastructure requires enormous investment long before a single customer uploads a file. The visible service is only the final layer. Beneath it exists years of planning, construction, engineering, and operational expertise. Modern civilization experiences the convenience. Very few people ever see the infrastructure that delivers it. That separation between experience and architecture is precisely what makes the cloud appear invisible. But the further we look beneath the surface, the more physical the digital world becomes. A cloud service appears almost instantaneous. You open an application, the information is already there. A document loads within seconds. an AI model begins responding almost immediately. The experience feels simple because almost every layer of complexity has been hidden. In reality, every request begins a carefully coordinated journey. The moment you press a button, your device sends a request through a local network. That request travels across fiber optic infrastructure toward an internet exchange. From there, it may cross cities, countries, or even oceans before reaching a destination. Eventually, the request arrives at a data center. Inside that facility, networking equipment determines where the request should be processed. Servers retrieve information from storage systems. Processors execute calculations. Additional servers verify security, balance workloads, and prepare the response. Only after thousands of individual operations have been completed does the information begin traveling back to your device. The entire process often finishes in less than a second. Speed is not created by luck, it is engineered. Cloud architecture is designed to minimize distance, reduce latency, distribute workloads, and eliminate single points of failure. Every additional millisecond matters. A slower application affects user experience. A delayed financial transaction affects businesses. A slower AI response changes how people interact with technology. Performance, therefore, becomes part of the infrastructure itself. This explains why cloud providers continuously expand their global presence. Building larger data centers is only one part of the equation. They must also build networks that move information with extraordinary efficiency. The cloud is not a single location. It is an interconnected architecture operating across thousands of physical facilities, linked together by one of the largest communication networks ever constructed. This is where the cloud begins to reveal its true nature. It is not simply a collection of computers. It is a global infrastructure designed to make distance almost disappear. And once distance begins to disappear, entire industries begin to change. If cloud computing has become essential to modern civilization, why don't thousands of companies build their own global cloud platforms? The answer is not software. It is infrastructure. Building a cloud platform begins long before the first customer creates an account. It begins with land, reliable electricity, fiber optic connectivity, cooling systems, physical security, engineering expertise, and billions of dollars invested years before meaningful revenue is generated. A single hyperscale data center represents an enormous capital commitment. Operating hundreds of them across multiple continents requires an entirely different level of investment. But constructing buildings is only the beginning. Each facility must be connected to regional fiber networks. Power capacity must continue expanding as demand grows. Hardware must be replaced continuously. Software platforms must remain compatible across every region. Cybersecurity operates every second. Engineers monitor performance around the clock. Every layer increases both capability and complexity. This is why scale matters. Larger infrastructure reduces the average cost of delivering computing services. More customers generate more demand. More demand justifies larger investments. Larger investments improve performance. Better performance attracts even more customers. The architecture begins reinforcing itself. Economists often describe this as economies of scale. System architects recognize something even more important. Scale creates resilience. A global cloud platform can redistribute workloads between regions when demand suddenly changes. If one facility experiences disruption, another can continue processing requests. Redundancy becomes part of the architecture. Availability improves. Confidence grows. Customers gradually begin trusting the platform with increasingly critical operations. At that point, the relationship changes. Businesses are no longer purchasing computing resources. They are building their own operations upon someone else's infrastructure. And once that happens, switching becomes significantly more difficult. The cloud is no longer just a service. It becomes part of the foundation beneath the modern economy. That foundation explains why only a small number of companies have managed to build cloud infrastructure at truly global scale. Not because others lack ambition, but because architecture on this scale requires extraordinary amounts of capital, engineering, time, and trust. And once trust becomes embedded within infrastructure, it becomes one of the most difficult advantages to replicate.
The true value of the cloud is not measured by the number of servers it contains. It is measured by the number of systems that depend upon it. Over the past 2 decades, cloud computing has gradually become the foundation beneath the digital economy. What began as a more efficient way to store information has evolved into infrastructure supporting entire industries. Banks process transactions through cloud platforms. Hospitals manage medical records using cloud services. Manufacturers coordinate production across multiple countries. Streaming platforms deliver billions of hours of content every month. Artificial intelligence trains and operates on cloud infrastructure designed for enormous computational workloads. Even governments increasingly depend upon cloud technologies to operate critical public services. Most people interact with the cloud dozens of times each day without realizing it. Opening a navigation app, watching a video, ordering transportation, making a payment, joining a video meeting, using an AI assistant. Each interaction appears independent. In reality, many of them rely upon the same underlying architecture. This is one of the defining characteristics of modern infrastructure. The most important systems become invisible because they become universal. Once a system reaches that point, its value changes. Customers are no longer purchasing a product, they are participating in an ecosystem. Applications begin connecting to other applications. Businesses build software around cloud services. Developers create products assuming cloud infrastructure will always be available.
Entire business models emerge because the architecture already exists. Dependency expands quietly, not through obligation, but through convenience. Every additional service makes the ecosystem more useful. Every new capability encourages deeper integration. Over time, leaving the platform becomes increasingly complex. Data must be transferred, applications must be redesigned, security systems must be rebuilt. Operational risks increase. The challenge is no longer technical alone. It becomes organizational, financial, strategic. This explains why cloud providers compete to become more than infrastructure companies. They seek to become the environment where modern businesses are created, operated, and expanded. Because the architecture supporting innovation often becomes more valuable than the innovation itself. And throughout history, the systems that become indispensable rarely remain ordinary infrastructure. They become strategic assets that influence the direction of entire economies. If cloud computing has become so valuable, why doesn't every customer simply move to another provider? From the outside, the decision appears straightforward. Infrastructure is infrastructure, storage is storage, computing is computing. In practice, the architecture is far more complex. Most organizations do not rely on a single cloud service. They rely on hundreds: virtual machines, databases, artificial intelligence platforms, identity management, cybersecurity, analytics, developer tools, content delivery networks, monitoring systems, backup services. Each component becomes connected to another. Over time, these connections form an architecture unique to that organization. Replacing the infrastructure is no longer a matter of copying information from one location to another. It requires rebuilding the relationships between thousands of interconnected systems. That process can take months, sometimes years. It also introduces significant operational risk. A failed migration can interrupt business operations. A configuration error can expose sensitive information. even a brief outage can affect millions of customers.
For many organizations, stability becomes more valuable than change. This creates an important principle found throughout modern civilization. The deeper an architecture becomes integrated, the more difficult it becomes to replace. The value no longer exists only in the infrastructure itself. It exists in everything that has been built upon it. Cities illustrate the same principle. Relocating one building is possible. Relocating an entire city is not. The challenge is not construction, it is coordination. Cloud infrastructure follows the same pattern. Applications, developers, suppliers, customers, and operational processes gradually organize themselves around a shared foundation. The architecture becomes stronger with every new connection. Economists often describe this as switching costs. From an architectural perspective, it represents something larger, accumulated dependency. The system becomes valuable because countless independent decisions reinforce it over time. No single decision creates the architecture, millions of decisions do. And once millions of decisions point in the same direction, the architecture begins reinforcing itself. That is why the world's most important infrastructures rarely dominate because they are impossible to compete against. They dominate because they become increasingly difficult to leave. And once an entire economy begins building upon the same foundation, the architecture itself becomes one of the most valuable assets ever created.
The importance of infrastructure is often easiest to understand by imagining its absence. Consider a world where the cloud suddenly disappears. Not one company, not one application, the entire architecture. Within minutes, billions of devices would begin losing access to the services they expect to be continuously available. Emails would stop synchronizing. Cloud storage would become inaccessible. Video conferences would disconnect. Streaming platforms would go offline. Navigation services would lose access to constantly updated information. Artificial intelligence platforms would no longer respond. The effects would extend far beyond consumer technology. Businesses would struggle to access operational data. Retailers could lose inventory visibility. Manufacturers would face interruptions across global production systems. Financial institutions would experience disruptions in services that increasingly depend upon cloud infrastructure. Hospitals could lose access to cloud-based medical applications. Airlines might encounter operational delays as digital systems become unavailable. Modern economies would not stop completely, but they would slow dramatically while organizations shifted to contingency procedures and restored critical operations. This thought experiment reveals an important principle. Infrastructure becomes essential long before people recognize its importance. Its value is rarely measured by what it produces. It is measured by what becomes impossible when it disappears. The cloud supports communication, commerce, research, healthcare, education, entertainment, artificial intelligence, and countless digital services operating behind the scenes. Most people never notice this architecture because it performs exactly as intended: continuous, reliable, invisible. That invisibility is not accidental. It is the ultimate objective of infrastructure design. The most successful systems become so dependable that they gradually disappear from everyday attention. People stop thinking about the architecture and begin focusing only on the experiences it enables. That is precisely what has happened to the cloud. It is no longer simply a technology platform. It has become part of the operating environment of modern civilization. And when infrastructure reaches that level of importance, its influence extends far beyond the companies that built it. It begins shaping how economies grow, how businesses compete, and how societies function every single day. The cloud is often described as a technology. In reality, it is infrastructure. That distinction changes everything. Technologies compete. Infrastructure enables competition. Technologies evolve rapidly. Infrastructure is designed to endure. Technologies create products. Infrastructure creates possibilities. This is why the cloud has become one of the defining architectures of the digital age. It allows startups to serve millions of users without building their own data centers. It allows researchers to process enormous data sets that would once have required supercomputers. It allows artificial intelligence to scale from experimental models to services used by hundreds of millions of people. Most importantly, it allows entirely new industries to emerge because the underlying architecture already exists. This pattern appears throughout history. Railroads accelerated industrialization because they transformed transportation into infrastructure. Electrical grids transformed factories because energy became continuously available. The internet transformed communication because information could move almost instantly across the world. Cloud computing represents the next layer in that evolution. It transforms computing itself into infrastructure. Once computing becomes infrastructure, innovation begins accelerating on top of it. Developers spend less time building foundations. Businesses spend less time managing hardware. Researchers spend less time acquiring computing resources. The architecture quietly absorbs those responsibilities. The result is larger than convenience. It changes the speed at which civilization can create. This reveals a broader principle that extends far beyond cloud computing. The most influential systems are rarely the ones people interact with directly. They are the systems supporting everything else. Their success is measured by invisibility. Their influence is measured by dependency. Their value is measured by the number of opportunities they make possible. This is why understanding modern civilization requires looking beneath the products we use every day. Behind every application is infrastructure. Behind every infrastructure is architecture. And behind every enduring architecture is a series of decisions that shaped how the modern world would eventually operate. The cloud is one of those decisions, not because it changed a single industry, but because it became part of the foundation beneath almost every industry. That is the difference between a successful technology and a civilization-scale architecture. One changes what people can do, the other changes what an entire society can become. Because the future is rarely built by the products people notice, it is built by the systems they eventually stop seeing. And once a system becomes invisible, it has often become indispensable. This is ASTIROZ, decoding the architecture of modern civilization.